Hello. How's it going, everybody? I wonder if you can hear me. Awesome. So I'll look for questions in the question section, and otherwise I'll just start talking about sensors. This session's on the RTX-based sensors, which are renderer-based, as opposed to the PhysX sensor, which use the collision geometry to do sensor. I think the easiest thing for me to do was to start up a script that we already have in our standalone examples. And that is called the RTX_lidar.py script. It's in our standalone examples folder in the Omni Isaac sensors extension. I can paste that folder in the chat. Let's see. Copy paste. Oh, you're not seeing a screen. Okay, that's probably not good. Well, on my stream, I'm seeing a screen. How do I remove that? How about now? Can you see a screen now? Okay, a warehouse is good. I'm gonna. You don't see a screen with the code because I'm cutting and pasting from another window, and I will paste that in chat. This is the example that I'm going to be running. That's how I got this LiDAR on the screen. There we go. If you have Isaac Sim installed, you can run that. Well, I hope you guys got it because it said I got an error. Worst case scenario, just follow along by my voice, I guess. GPU power. I believe we're at a 3070 now. I don't know for sure. Okay, I'm not yet able to share the script. If I'm not able to paste things in here, that's going to be a little problematic. Let me try without the dots. Oh, that one didn't give me an error. Awesome. So I'm running the python.sh script, and that's the script that I'm running. When you start up your screen, you'll get something like this in Isaac Sim. It'll probably be spinning, which I'm pausing for the cast for now. I wanted to show what goes on with these. The first thing the script does is it creates a sensor. Over here, you can see it in the property. You select in the window. If you look down at the properties, you can see that it's a LiDAR plugin. And you can see that the camera sensor type is LiDAR. This is all done with the Isaac sensor create RTX LiDAR script, which is in that, or command. The next thing it does is it creates a render product, and we want to be able to see the results, and they're rendered into a render product, which we have to grab with the node network. So the way we do that, if you go to Windows, visual scripting. No, we don't need the action graph right now. We need, yeah, we do want visual scripting action graph. So this post-process synthetic data generation pipeline is generated automatically when we attach the writer that was outputting the debug cloud, and it created these nodes. This is the node that creates the point cloud, and this is the node that receives the pointer from the renderer. This one's important if you want to print out some debugging information. For instance, if you wanted to use the print, we have an RTX print Lidar info node that will allow you can look at that as an example to sort of do your own thing with the render results pointer. And I don't know if it doesn't print on console. It prints on the terminal in where you launched when you hit play. So for me, that is my, let me see if I can share another window. It will be nice to be able to share that. All right, you can see all that stuff being printed out there. That's from the debug node that was attached. And I'd like to switch back to the other one. All right. Noted. Prints in terminal instead of console. Okay. All right. So the other one that's important. Somebody was asking a question in the forum recently about what do you do with this data? How do you use it? If you're in the session, if you're in Isaac Sim and you're just in the scene, you can access any data from any node with a script editor, some Python scripts. So a good example would be, let me just get the whole thing in there. I can run them pieces at a time. All right. That is a little hard to see. Sorry about the size. I don't know how to make that bigger. Anyway, this section down here is what will grab it from the node. Well, it does weird things with periods. Sorry about that, guys. Okay, that looks readable to me. If you'll notice the name of the node here, that's in the action graph. You can click on the node itself to see the name. It's right here in the path. So you do og.controller.node, and then you get whatever node you want. After you have the node, you can get the attribute. The attribute we want is the point clouds coming out of it. You can hover over and see that is called outputs point cloud data. And we just did a simple print, and trust me, it printed in my console. The data's there. So it can be attached to a robot. Let's see, I don't have an example of one where it's moving. I'm a engineer for the Lidar, but if this was a robot moving it around instead of me, you can still see that it does move around. It will also render any moving characters if that's what you're asking about, because it sees everything the renderer sees. Well, so I am creating a point cloud. Somebody asked if what kind of data are we getting? Are we getting a point cloud? So the answer to that is yes. This Isaac Compute RTX Lidar point cloud computes the point cloud from the rendered return data. The render return is sort of a raw pointer to all the returns you want, which you can then turn into point clouds. Um, you'd have to transform it into world space and uh, you know sort the data. That print node is a good example of something that you can see parses the pointer from the renderer. The pointer from the renderer comes from this node. If you wanted to start your own scene and not use that example, I wonder if I should do something like that, build a scene from scratch. Would that help people? We typically send the data. Somebody asked, how do we typically view the data? So typically what we do is we hook it up to ROS nodes for output instead of this debug viewer. The debug viewer is kind of slow. I mean, it doesn't do anything special. So it just adds those points to the scene, and it can add a little bit of rendering time. But it allows me as a developer to see what's going on. What uh, robot engineers would usually do is attach it to a ROS2 helpers and output to there. So I guess let me close this and start a new session with a new scene, and I'll build one from scratch. All right, here is a freshly started Isaac Sim session. We can first just, okay, it should be sharing a window with a blank Isaac Sim session. Yeah, I'll use that warehouse. Might as well keep using the warehouse. All right, there is our warehouse. Now to add I think there are UI things that can add sensors. Let me see if I don't use those. So let's find out what they do. uh, this one might, if I remember, might have a bug in it right now, but we'll see. Okay, that doesn't look like it created anything. So let's go look at the action graph and see if we can fix that. Visual scripting, action graph, no graphs found. That's because we didn't attach any kind of render products. I'll do it the way I know how to do it. And that would be with a script editor. All right. So the first thing you need to do is run this command, the Isaac sensor create Lidar, and to call those commands, you'd use the OmniKit commands execute. Send in all your parameters. This example rotary is a config file. We can take a look at that in a minute. That's what controls what the beam locations and how fast they shoot, and what the properties of the lidar itself are, or if it's rotating or if it's solid state. Let's see. After that, okay, so let's do that. Let's just create it first. When you're in the script editor, you can highlight ones you want to do and not enter the whole thing. When you highlight and hit Control Enter, it just runs that little snippet. It does not doing anything yet. The camera exists, and I believe the renderer wants to render it, but it doesn't have anywhere to put it. So you have to create a texture for it to be put onto. That's what this create hydra texture does. It creates a texture in the background that's not attached to any viewports that the renderer can render to. And that's all well and good. The renderer has now created some place where it's going. We're definitely rendering, but we can't see or do anything with it. Oh, yeah. So somebody asked, when using the config file, does it get the config on startup? The answer is yes. When the sensor is created, that's when the configuration is used. So changing the configuration file after the sensor is in the scene isn't going to work. If you just delete the sensor and recreate a new one, like if you made a change to the configuration file, you'd have to delete it and create a new one for it to pick up the changes. So anyway, we've got the texture created, and now we need to create a node network that will let us access that data. That's what we do with the replicator writer. Replicator has lots of things it can write out. One of the things it does is grab Lidar data. I'm going to go ahead and create the writer. And once we create that node network, that actually lets us see things on the screen because the writer I created, whoops, oh, that's not horrible. The writer that I created was this debug draw point cloud node. When I called the action to create that, it built the network behind it automatically. So all this extra stuff was put in. You don't have to worry about it. It does all the connections for you. The debug draw one that I drew creates the actual point cloud one. This one shows nothing. It just output those points, which you can get again with this OmniGraph controller. Grabs nodes, and once you have the node, you can grab, you can grab any attribute off of it. Let's see. Let's go look at a configuration file. I think that might be useful. I'm not seeing. Let me read through, make sure I'm not missing any questions. Yeah, computer. Nothing obvious to me. Okay. I think the configuration file should probably be shared in my editor. Do I have one open? And I'll have to share that with you guys soon. I'm switching over to my editor. All right, here's a configuration file. This is our default one. I want to be able to twin results from sim to real. Well, yeah, that one involves grabbing the data and doing some of your own training and then trying to see if that controller works in a real robot. It's a little bit beyond the scope of this. So Siren says they're not clear. If you can, wasn't sure. Does ROS need to be installed to run this? No, ROS does not need to be installed to use the RTX sensors. The one that I'm showing you for the debug viewer doesn't have any ROS in it at all. It just outputs to the screen and renders the points. If I wanted to output to ROS, I'd run a different example and use those nodes. There's examples for those in the place where I showed you the debug draw example. There's ones that are the same thing, but for ROS bridge examples. They're named the same. ROS2 bridge and ROS bridge both have them. Okay, we need a real LiDAR. Can we make Isaac sensors identical to the purchased LiDAR sensors? Pretty much. That's what we do with the example LiDARs that come with Isaac Sim. So let's see. Well, I believe we have. Yeah, I don't know which companies we have. I'd have to go look at the documentation, which I can send you the link to. And that would be in there. It shows which ones we have. So I can go over a few of them. Obviously, this type is either going to be rotary or solid state. This is all in the documentation that I just posted a link to. One thing that was added, uh, which allows you to put the LiDAR inside. I don't know if it's in this. This is not in this file by default. But if you want to make, like if there's sensors inside of a housing and you don't want it to hit the housing, you can make that go away now. Or not start firing the laser until after it's out of the housing. I wonder which one that is. Partway down the file, you can see a link called LiDAR config file parameters, or partway down the manual page. The range offset is the one you want to use if you have a housing. That's not in the default config, but you can add it. So the way I create the LiDAR files that are supposed to be realistic is I grab the manual and get as much information as I can. Some of the LiDARs allow you to read off them and see what the firing patterns are and the times are. You could put those in. It takes a couple hours, but it works. Yeah. So I think I've hit all the forum questions I could think of. You guys coming up with anything? Oh, people were asking about materials. Those are a little complex. We have a CSV file in the documentation. You can see where it is, where you take. I should switch back to IsaacSim for this. I'm going to talk about adding materials to your objects in the scene. Okay. So let's create a cube. Where did I create that at? There it is. Selecting the sensor is difficult since it doesn't have an icon on the window. I should consider that. So this block isn't going to have any sensor material on it right now because I haven't added any materials. The material you generally add are visual materials. So if I went ahead and created a material here, something like OmniGlass, I would recompile the shaders really quickly, and then you would have something on that cube. So let me select that cube. I think I didn't put it under the root, or I did, and that's the problem. I'm just going to start a new scene. And I'll go to script editor and run those scripts to create a LiDAR. And see what I did wrong. The sensor was created. Couldn't find OmniGlass. OmniGraph render. That's because it's probably not named the same thing. Let's see if we did create one. We want to grab the data from this node. Hopefully that'll work. Let's try that again. There we go. Now data from the correct node. Back to materials. We're going to create a cube. We're going to right-click the cube. You can add materials many ways. This is the way I know how to do it. Create material, OmniGlass. And let me create another cube here so we can see that one. All right. So I wonder if our Lidar is actually connected to anything, because I didn't test this script out before I ran it. Here we go. It's there. And it was there before. It was just inside the cube. All right, materials. So the visual material that's out of this cube has a way to get to the sensor material that's not really associated with material property. It's associated with the material name. So down here you can see world/look/OmniGlass. That is the material that is attached to that cube. You take the section that is after looks, which is OmniGlass, and you add that to a CSV file that is loaded at, I believe, the plugin startup. So the first time you create a sensor in the scene, that CSV file is loaded. I think it could be when Isaac Sim starts, so you might have to restart. But I mean, either way, you'd have to restart if you made changes, because it would be the first time the sensor's in. You do that, and then you where do we put that setting for material? It's in a CSV file and in the documentation. I should be reading that page. Yeah, why not my web browser? All right. So sensor materials, RTX sensor materials. These names here are all of the material types that you can have. When you add them, this setting here, which should not be changed as one of our settings for the extension, it associates all the names above, adding the name material at the end, with an index. So those indices are what the Lidar will return and the material ID return. So the CSV file, do I say where that is? Yeah, there we go. Kit rendering data, RTX sensor material map.csv. That's the one where you add entries into. Entries look like this. So in our case, for the example we had, it would be OmniGlass, which is the material attached to the cube, and comma, maybe we'd want to standard glass material or something. It would be glass standard, I think is what it's called. Yep. Once you have that, it should output, it should act like that material is attached. what I've tested is that it outputs the ID of the materials. If you have glass, you need multiple returns so that it can go through the glass. So just having one return would probably return the glass. It might return the strongest. Okay, that is not the right thing to do. Well, I'm going to have to. There we go. Go back to my Isaac session. All right, let's see if we got. Yep, range offset was right. Sadly, I'm just back and Isaac just updated and this crashed in startup. Okay. I'll wait around a bit, see if we have any more questions. How do I deal with vibrations in the sensor, either from a drone in flight or from rover or bad data? Can we twin those distortions in Omni, or does it matter? You're still talking about the sim to real. I'm not an expert in that. I can say that yes, you can add noise to the data, the virtual data that you're getting any way you want. So you could grab the data from the node with that OG controller, OmniGraph controller in Python, and then distort those points. The point cloud node creator itself, the one that creates the point cloud, not draws it, has, let's see if I remember right. Maybe that's in the, no, I think it's supposed to be in there. Yeah, so it has some errors you can add in like just offsets. If your thing was registering, these are global offsets for all points. The other option would be parameters in the config file, which have some mean and standard deviation. There's an azimuth error. If you add those in, it'll jitter the points around. The elevation and the azimuth can both be jittered around. If you wanted to add it yourself, you would grab the data from the node and do that. Is that necessary for the training? Maybe. Copying the errors you get from a real world sensor into synthetic data is not a small problem. I mean, you'd have to try to copy the same way it's doing it and figure out if your noise is the same type of noise. Can we go over each of these node attributes? Yeah, let's see if there's the questions before. Has this been great? Got some questions answered. I got my system running. I'll run the script and hopefully try this out. Okay. Hopefully it'll build up. I mean, I can stay for a while longer. Okay, and yeah, let's go over some of the parameters of the output. This intensity is it's going to be between 0 and 1, and it's the intensity of the return. So if it hit something and it was a good read, it would be closer to 1. Azimuth and elevation they're all vectors for each points of those parameters that come out as raw data, not in any kind of as in the sensor coordinate system. So they're just angles. Point cloud data is let's see. You know what I should do? I should show you the node that reads all of the data. There's another node that doesn't create point clouds but reads data. So we have some nodes. The flat scan one is actually creates a Lidar message for ROS, or at least in the format that our ROS thing can read, and then you'd output that into a ROS node. It just creates a slice of the thing as if it's a 2D Lidar, no matter what your configuration is. It will use the timing on the configuration, but it will only pick up the center ones. Let's see, read LiDAR. So read LiDAR point cloud data. That's the one that will output everything from the pointer here. All right. Well, when you have this one, the azimuth, same as before. The beam ID uh, is something you can put into the configuration at the bottom for the beams. It's not used unless you put it in there yourself. So if you wanted to know which ones they are based on a number you'd put in, you'd do that. Distance is obviously distance to the target. The echo ID is when you have multiple returns, it's going to tell you which return number that was. Same with which emitter comes out of. In the configuration file, you set the number of emitters. Hit port normal is going to be in world coordinates, I believe, in render coordinates. Yeah, intensity is the same. Material ID we discussed. So if you want to do something else with the material aside from what the Lidar did internally, you can. Now, object ID is something that I've been told you can grab any object from the scene that it gets, but I don't know how to do that yet. So in theory, you take the object ID and put it into a script, and it will give you the prim that it hit. Tick, timestamps. Let's see how to describe. I mean, the number of ticks per render frame can vary, and that will tell you which one it is. Same with the timestamps. The velocity is again in world coordinates. That's all the outputs. Time of flight data. What you have is the firing time in the timestamp nanoseconds. You do not get the return time. You get the firing time. So I don't know if you would, if that's what you need for time of flight. I don't know if you get that. Well, when SteamYard starts working on Discord, I'm sure we'll have our people do that. So I like Discord as well. Okay. Any more questions? Well, how do we connect this to a ROS node? That I will try to do that. What I have, I can run the ROS 2 nodes. I wonder if I could run the ROS ones. Yeah, well, it's been a while since I ran ROS. I know I have to start up ROS core. Noetics, what I have installed. I hope that's ROS 1. Okay, I've started ROS core running, so hopefully when I run the example that has a ROS, let's see, where do I want it? I'll start over with that one. So the example I'm going to run is going to be, I will paste it in the terminal. After you get ROS running, once I get that started, I will open up my screen and you'll see my session. All right, so in that example, we do the same thing as last time, but we create an extra node. Action graph. So here's our point cloud and our, where's that debug draw? It's around. So here's the debug draw one. We also created two other ones. One that takes in that flat scan I mentioned. It creates a flat scan, publish the flat scan to ROS. The other one publishes the point cloud to ROS. Now, let's see if I can remember how to get our view running so you can see that it actually is going to ROS. Right now, it's sending messages to ROS. If somebody wants to tell me what command they want me to run at the terminal to give them ROS information, I can. So LiDAR work in water, that depends on if you tell it it's in water. It does have a setting for rain, which I think is mentioned in the documentation. I bet if you put that to 100%, it would act like it was inside water. I mean, would your real one work? I don't know. I think it would die. See, reading through. Yep. No setting for snow yet. Yeah, depending on the model. I'd like to remember how to do our view. I think it might be in the documentation. Let me just send a second while you guys are thinking of more questions to look for that. We have a... Okay, RViz /D or -D. See if this works. Workspace, source, tutorials. I didn't sort it in that terminal. All right. The scene was a scene. Let's go back and hit play, see if I can show you some ROS output. It's playing. Yeah, I'm afraid I don't know ROS well enough to show you guys what's going on with this. Which is a little sad, but what can you do? Other types of sensors. Well, I mean, if you dig around in the examples, you'll see that we have a radar example, and the nodes for LiDAR match the ones for radar. Or the ones for radar match the ones for LiDAR, but we have no documentation on it, and I've never looked into what the parameters on the configuration files do. So you'd have to suss all that out yourself. RealSense depth cameras, I believe we ship with a model of the RealSense. All that is a placement of a couple cameras in the same position as they are on the actual RealSense. You'd have to get your stereo answer yourself. We don't have the RealSense stereo algorithm. That's in the hardware. More general solution about training models. So do you just port the scene over to GEM and run a ton of training sims through? Yeah, that'd be one way to do it. GEM's pretty good. Customize the models that you're using this Lidar on, or customize the Lidar themselves? Oh, customize what the camera looks like in the scene if you have a RealSense camera. So, I mean, you can save out your own camera USD files. If you save as ASCII, oh, the interocular is, yeah, you can just load up, save the camera out as a text file, a USDA file, and you can look at where the positions of those are and just change them by hand. You can probably load up the USD asset and select, I'm pretty sure you can actually, select the individual cameras and move them yourself in the UI. Let's see. See if I can create. No, I'll just go to see if I can remember where those RealSense cameras are. No. I don't want to do that. I want to add it to the scene. All right. So flashing. All right. I think, let's see if we can do this. Yeah, I don't know why it doesn't show the camera itself. If you look in the camera, you can see the right, left, the color ones in the center. It's the color sensor is just another camera. You could take these and move them. These are the relative positions. You could change the relative positions if you wanted. You'd have to save out your own version of it, obviously, because ours is read-only. I think that's about it for me. So I hope you guys learned something, and have a good day, guys. Oh, real quick, any suggestions, best practices of workflow for synthesizing LiDAR and vision depth data? Yeah, use Replicator in Omniverse. I do check the forums, but it's only every few weeks myself. We do have somebody who checks it a lot more. That tells me when to answer questions. All right, bye, guys.